Cardiac Perfusion, empowering the next generation for advancement in extracorporeal sciences and mechanical support. Introduction: the pulse of modern cardiac medicine. In the world of modern medicine, few fields are as critical, intricate, and life-saving as cardiac perfusion. It is the discipline that ensures the continuous circulation of oxygenated blood to the organs and tissues during cardiac surgery or when the heart and lungs are unable to function on their own. Perfusionists, the unsung heroes behind this complex process, manage the heart-lung machine, monitor vital parameters, and work hand-in-hand with cardiac surgeons and anesthesiologists to sustain life under the most delicate circumstances. This video is brought to you by Ghulam Farooq, a PhD research scholar in artificial intelligence at Unimarconi, Italy, and Pakistan's first AI technologist integrating artificial intelligence into medical, healthcare, and forensic sciences. He currently serves as Additional Director of Artificial Intelligence, Research, and Postgraduate Affairs at the Asian Institute of Medical Sciences and is a trainer, researcher, and YouTube content creator promoting AI in education and medicine. This video is dedicated to E-Commerce Gateway Pakistan Private Limited for organizing the seminar on cardiac perfusion, empowering the next generation for advancement in extracorporeal sciences and mechanical support, to be held on the 25th of October 2025 at the Karachi Expo Center, Pakistan. In today's rapidly advancing healthcare landscape, cardiac perfusion has evolved beyond being just a supportive discipline. It has become a vital frontier of innovation. With the integration of biomedical engineering, data analytics, and artificial intelligence, perfusion science is moving toward greater precision, safety, and personalized patient care. The new generation of perfusionists is stepping into an era where human expertise and machine intelligence are seamlessly blending to redefine survival possibilities in cardiac and critical care. Evolution of extracorporeal sciences. The journey of extracorporeal sciences is a story of extraordinary progress. Decades ago, the invention of the heart-lung machine revolutionized cardiac surgery by allowing surgeons to operate on a motionless heart while maintaining systemic circulation. Today, that legacy has evolved into highly advanced extracorporeal membrane oxygenation (ECMO) systems, machines that can temporarily replace both heart and lung functions. ECMO is now a lifeline for patients suffering from acute respiratory distress, cardiogenic shock, or severe cardiac failure. Over the past decade, the integration of sensor-based technologies, smarter monitoring systems, and miniaturized components has made ECMO safer, more portable, and more accessible. From neonatal care units to adult intensive care settings, ECMO is bridging the gap between critical illness and recovery. The concept of extracorporeal life support has expanded from the operation theater to emergency transport and disaster medicine, showing how far the field has come in its mission to preserve life. Latest research and innovations in cardiac perfusion and ECMO. Recent research in cardiac perfusion and ECMO focuses on enhancing biocompatibility, automation, and intelligence within perfusion circuits. Scientists and engineers are developing next-generation oxygenators coated with advanced nanomaterials to reduce blood cell damage and inflammatory responses. These surfaces not only prolong circuit life, but also improve oxygen transfer efficiency and patient safety. Artificial intelligence is revolutionizing the perfusion process. Machine learning algorithms now analyze hundreds of data points per second to predict potential complications such as air embolism, hemolysis, or hemodynamic instability. Smart perfusion consoles automatically adjust pump flow and pressure according to real-time physiological changes, ensuring optimal tissue perfusion even during fluctuating surgical conditions. Furthermore, portable ECMO devices are emerging as game changers, designed to support patients outside the traditional ICU. Research teams are exploring wearable ECMO units that can sustain mobility and quality of life for patients awaiting transplantation. These technological leaps are transforming the field from manual control to intelligent life support ecosystems. Breakthroughs in mechanical circulatory support systems. Beyond ECMO, the field of mechanical circulatory support, MCS, is redefining the future of cardiac recovery. Devices such as ventricular assist devices, VADS, impeller pumps, and total artificial hearts, TAAH, have provided extended survival and better quality of life for patients with end-stage heart failure. The most recent innovations include magnetically levitated pumps that eliminate friction, reducing wear and tear while minimizing blood trauma. Wireless power transmission technology is being incorporated into implantable devices, allowing patients greater freedom without external driveline connections. The introduction of biologically integrated sensors now enables real-time feedback on cardiac performance, helping clinicians adjust treatment protocols instantly. In parallel, research into biohybrid circulatory systems, which combine living tissues with mechanical components, is showing promising results. Scientists envision future heart assist devices that can grow, repair, or adapt alongside human tissue. This extraordinary fusion of biology and technology marks the beginning of a new era in mechanical circulatory support, where machines not only assist life, but evolve with it. Training the next generation of perfusionists. Despite these remarkable advancements, technology alone cannot save lives. Skilled professionals are the heart of the system. The next generation of perfusionists will be the true drivers of change in extracorporeal sciences. Their expertise, decision-making, and situational awareness are what bridge the gap between technology and human survival. The role of the perfusionist has expanded beyond the operating room. They are now involved in intensive care management, ECMO initiation in emergency medicine, and even in remote telemonitoring of life support systems. This increasing scope demands a stronger emphasis on education, research, and professional development. Globally, hospitals and universities are recognizing the need to train perfusionists who not only understand physiology but also master data interpretation, system design, and troubleshooting under pressure. The perfusionist of the future will be a hybrid professional, a clinician, technologist, and researcher, all in one. Modern education and simulation in perfusion training. To meet this demand, education in cardiac perfusion is undergoing its own transformation. High-fidelity simulation labs now allow trainees to practice entire cardiac bypass procedures on virtual patients, experiencing real-time feedback from simulated hemodynamic responses. These simulators replicate the complexity of clinical scenarios, including emergencies such as air entrainment or pump failure, without putting actual patients at risk. Digital twin technology, an innovation borrowed from engineering, now enables educators to create patient-specific models where perfusion strategies can be tested and refined before surgery. Additionally, virtual reality, VR, and augmented reality, AR, are helping learners visualize cardiac anatomy, circuit flow dynamics, and oxygenator mechanisms in a fully immersive 3D space. Online learning platforms, webinars, and global certification programs are also breaking barriers, enabling professionals from developing nations to gain access to world-class education. This global connectivity ensures that perfusion knowledge is no longer limited by geography. It is shared, enhanced, and continually evolving. Collaboration and networking for advancement. Empowering the future of cardiac perfusion requires a strong ecosystem of collaboration. Surgeons, perfusionists, biomedical engineers, and healthcare leaders must come together to build a framework of innovation. Interdisciplinary teamwork enhances understanding and encourages the co-design of technologies that meet real clinical needs. International conferences, workshops, and symposiums play a crucial role in this journey. These events not only showcase groundbreaking research, but also foster professional relationships that drive collective growth. Networking among perfusionists and clinicians helps share best practices, standardize protocols, and ensure that every patient, regardless of location, receives the highest standard of care. Collaboration with industry leaders also paves the way for translating academic discoveries into practical devices and systems, ensuring that the bench-to-bedside transition happens efficiently and safely. The future of extracorporeal sciences. Looking ahead, the future of extracorporeal sciences lies in the convergence of human intelligence, robotics, and artificial cognition. AI-assisted perfusion consoles will soon integrate patient history, imaging data, and live hemodynamic readings to guide clinical decisions with unmatched accuracy. Robotic-assisted cannulation and fully automated bypass systems are already being prototyped, promising faster setup and fewer human errors. We are also entering an era where predictive perfusion will become a reality. Systems capable of anticipating a patient's physiological needs before they change using continuous learning algorithms. The integration of cloud-based monitoring platforms will allow specialists to supervise ECMO or VAD patients remotely, ensuring uninterrupted support even in resource-limited settings. This future represents a new philosophy, technology and humanity working hand in hand, where machines amplify the capabilities of clinicians and clinicians direct machines with empathy and wisdom. Inspiration for the next generation. The world needs passionate, curious, and courageous young perfusionists who see their profession not merely as a job, but as a mission to save lives. The next generation must embrace innovation, pursue continuous learning, and carry forward the ethical commitment to excellence that defines this field. Every successful bypass, every recovered patient, every life sustained through a perfusion circuit is a reminder of how science, skill, and compassion can converge into a miracle. Institutions must nurture this spirit by offering mentorship, supporting research, and encouraging interdisciplinary collaboration. By doing so, we will not only advance perfusion science but also inspire a new era of healthcare innovation across disciplines. Closing message: a celebration of human resilience. In the grand journey of medical science, cardiac perfusion represents more than technology. It symbolizes hope, precision, and the triumph of human resilience. Behind every beating heart sustained by an extracorporeal system stands a team of visionaries, surgeons, perfusionists, and engineers united by one purpose: to preserve life. Thank you for watching and staying with me. If you found this video helpful, don't forget to like, share, subscribe, and hit the bell icon so you never miss my latest insights on Maams AI-powered forensic medicine and toxicology. Also, I invite you to visit my other medical channel, Medicology, which features a wide range of AI-powered 3D medical procedures. If you have any questions, feel free to leave them in the comments below. I'll respond as soon as possible. This is Ghulam Farooq signing off. Until next time, stay curious, stay inspired, and keep learning.